Hello and welcome to the second video of my PLC Basic course. I'm excited to have you here. In this video we will take a look at PLC hardware. Let's get started. In the previous video we talked a little bit about PLC hardware. You should already know that this is a Siemens Simatic S7 1200 and this is a Siemens Simatic S7 1500 controller. Now we will learn more about this huge topic. I would also like to introduce you to a few other manufacturers of programmable logic controllers. This video will be a bit longer, so grab a cup of coffee and then let's go. There are countless manufacturers of programmable logic controllers in this world, like sand on the beach or water in the ocean. I would like to introduce you to a few well-established brands. In Germany, for example, the manufacturers Vago and Beckhoff are well known. Vago produces its own PLCs but uses the independent software Codesys for programming. Beckhoff produces industrial PCs which can also perform the tasks of a PLC. Programming is done using the software TwinCAD. Other well-known manufacturers are ABB from Switzerland and Schneider Electric from France. You may also have heard of Allen Bradley. The company is part of Rockwell Automation and has a strong presence in the American market. In Asia, for example, the Japanese manufacturers Mitsubishi and Omron are more strongly represented. The type of controller you find in your electric cabinet often depends on the continent you live on. In Europe, there is a clear market leader, Siemens. Siemens is a German company. Their PLCs are called Simatic. The devices are programmed using the software TIA Portal. Siemens is used worldwide. It's a good choice to learn PLC programming using the devices of this manufacturer. For this reason, we will work with Siemens PLCs during the course. Let's take a closer look at Siemens PLCs. Simatic controllers have been around since the 1960s. We categorize Siemens PLCs into three columns: new, old and very old devices. Believe it or not, many Simatic S5 controllers from 1979 are still in use today. The S5 is considered the grandfather among the Siemens PLCs. In 1994, the new generation of controllers Simatic S7 was launched. This includes the devices Simatic S7 300 and Simatic S7 400. The S7 300 is used for small to medium-sized systems, while the S7 400 handles larger, complex applications. You can still order S7 300 and 400 controllers, but starting in 2025 they will only be available as a spare part. Even in 10 to 20 years you will find these PLCs widely used. However, new systems will usually no longer be equipped with this generation of controllers. The new generation of Siemens PLCs is still called Simatic S7, but is divided into the S7 1200 and the S7 1500 series. The S7 1200 is suitable for small to medium-sized systems. The S7 1500 is used for more extensive and complex applications. In new systems, you will likely find one of these two controllers. The S7 1200 is more affordable than the S7 1500. This is the reason why we will focus on the smaller controller during the course. But don't worry, we'll cover the essentials of the S7 1500 too. Now let's break down the parts of a PLC. I have assembled an industrial control system for us. Here on the left you see the power supply, which converts mains voltage to 24 volt DC for the PLC. Once powered on, the power LED lights up and the CPU display activates. The next part of our PLC is the CPU. The CPU is the brain of our controller. This is where we transfer our project. The connection to the controller is made with a network cable. The Simatic S7 1500 requires a memory card. With the S7-1200, this is optional. The next modules are input and output cards. Here we can connect our sensors and actuators. In this image you can see the components of our PLC. The so-called front connectors are used to connect the cables of the sensors and actuators with the input and output cards. The U connector establishes electrical and communication connections between the modules. All modules are mounted on a special rail. And now guys, you have some time to relax. You can watch me for a few seconds as I assemble the PLC. Let's go to the workbench. First, I install the power supply. The S7-1500 requires a memory card. The U connector ensures data exchange between the modules. We can connect the cables of the sensors and actuators to the front connectors of the input and output cards. Wonderful! Our PLC is ready. We can now install it in the electrical control cabinet. As a PLC programmer, by the way, this will be your second home. You will spend a lot of time here during commissioning or troubleshooting. We already know that sensors and actuators are connected to the input and output cards. What we don't know yet is that there are two different types of input and output cards. Digital and analog. Depending on the type of sensor or actuator used, you will need different input and output cards. Let's take a closer look. In a PLC, we differentiate between digital and analog signals. A digital signal can have only two states. An analog signal can have many different states. Let's look at two simple examples. A switch is a good example for a digital or discrete sensor. It can only have two states. It can either be on or off. A typical voltage in the world of automation is 0 volt or 24 volt DC. A good example for an analog sensor is a dimmer. You can use it to set any value between two limits. Typical for PLC is 0 to 10 volt or 4 to 20 milliampere. Siemens offers suitable input and output modules for digital and analog sensors and actuators. You can see for which type of sensor or actuator the module is designed for by reading the small label on the front. DI stands for digital input. You can connect 32 discrete sensors to this module which supply a 24 volt signal. DQ stands for digital output. You can connect 32 discrete actuators to this module which require a 24 volt DC signal. For example, 32 contactors and relays. AI stands for analog input. You can connect 8 analog sensors to this module. AQ stands for analog output. You can connect 4 analog actuators to this module. You may have noticed the small letters on the modules. These provide information about additional technical properties and functions. BA modules are for very simple applications. ST modules are for standard applications. HF modules have more diagnostic capabilities. HS modules can process signals very quickly. For you as a PLC newcomer, this is not so important yet. Standard modules are suitable for 95% of all applications. That's something you should keep in mind. In the PLC Basic course, we will be working only with digital signals. Digital signals are the most common signals in automation. We will also repeat much of what we've just learned, so don't worry if you feel like you're not understanding everything right now. Now, my friends, it's time for a very short break. You've learned a lot. Take a second to relax. Alright, break is over. Let's continue exploring the Siemens S7 1500 CPUs. If you want to know which CPUs your TIA portal version supports, click on Add New Device. Of course, I will show you exactly where to find this in a later video. If you now click on Simatic S7 1500, you will see many different controllers. I would like to quickly show you what the differences are. Here, for example, you can see a CPU 15131PN. If you click on the same device in the TIA portal, you will get more information about this device. This can be very useful. Now I would like to show you another CPU. The CPU 1517F3PNDP is something like the Ferrari of PLCs. If you want to spend a lot of money, this is a PLC of your choice. This device is suitable for large systems and complex applications. Now I want to explain you what exactly the designation of the CPU stands for. This way, the next time you open a control cabinet, you will immediately have some information about the controller being used. 15 stands for the generation of the controller. It's therefore a Simatic S7 1500. The next two digits provide information about the performance and expandability of the CPU. The higher the number, the more internal memory the CPU has and more complex program it can handle. For example, the CPU 1517 has more power than the CPU 1511. Of course, this also has an effect on the price of the device. The F in the name stands for failsafe. With a failsafe CPU, you can also implement safety functions like emergency stop. If you find a C in the name of your controller, it means it's a compact PLC. These already have pre-installed input and output modules. If you find a T in the name of your controller, it means it's a technology CPU. A T CPU is designed to handle advanced technological tasks in addition to standard functions. For example, advanced motion control. The remaining numbers and letters provide information about the available interfaces of the CPU. What I mean can be easily seen when you open the covers of the CPU. Here you can see the DP interface, which is for Profibus. On the left side, you will see 3 LAN ports. These can be used for Profinet. Profibus and Profinet can be used to exchange information with other devices. However, Profibus is considered to be outdated. Profinet is now the new standard. But there is still a controller with a Profibus port available. Alright everyone, we have reached a milestone. Congratulations! We are now familiar with the Simatic S7 1500. Next, we will take a look at the S7 1200. When you add a new device in the TIA portal, you will see all the supported devices. The S7 1200 is suitable for small to medium-sized systems. There are slightly fewer devices compared to the Simatic S7 1500. Let's look at an example together. Here you can see the CPU 1212C AC-DC relay. In the TIA portal you find a description of the device again. But the name of the controller also contains important information. The first 2 digits again represent the generation of the controller. In our case, it's a Simatic S7 1200. The second 2 digits describes the performance and expandability. For example, a CPU 1211 cannot be expanded, while the CPU 1212 can. The CPU 1212 has less work memory than the CPU 1217. You can find details about this in the manual of each controller. There are also digital and analog expansion modules for the S7-1200. These are placed to the right of the CPU and connected to each other by using the built-in bus connector. By the way, the S7-1200 is not mounted on a special rack, but on a simple DIN rail. Every S7-1200 is a compact CPU. This means that the controllers always have pre-installed inputs and outputs, which differ in the number and type. No front connector is required. The terminals are pre-installed at the factory. Some of the Simatic S7-1200 CPUs can also be used for safety functions such as emergency stop. The last part indicates the power supply as well as the type of inputs and outputs. An AC CPU has an internal power supply and can be operated, for example, at 230 volt AC. A DC CPU requires an external power supply as it operates on 24 volt DC. A S7-1200 always has DC inputs. This means that they expect a 24 volt DC input signal. For the outputs, there are DC and relay outputs available. DC outputs always supply 24 volt DC, while relay outputs can be wired to other voltages. The CPU 1211, 1212 and 1214 have only one LAN port. The other controllers have two LAN ports. These LAN ports can be also used for Profinet. For Profibus, there are expansion modules available. If you're looking for a training PLC, I recommend the S7-1200. It's much more affordable than the S7-1500. If you can't afford none of them at the moment, don't worry. Later in the course, I will show you how to learn PLC programming in a practical way without spending a single cent. There are some great ways to simulate PLCs and machines. At the end of 2024, Siemens introduced a new version of the S7-1200. The S7-1200 G2 is the second generation of this controller. You can program the device starting with TIA V20. The S7-1200 G2 features higher performance, an NFC interface, and integrated motion functions. Now it's time for a short break again. I will quickly show you how to assemble a S7-1200. Now you know the basics about the S7-1200 and 1500. Great job! But there are a few more things I'd like to share with you before we move on. An obvious difference between the S7-1200 and the S7-1500 is the display. The Simatic S7-1500 has a small screen. You can use it to read out various information. For example, you can view the operating status, the IP address, various settings, as well as any warnings or faults. The S7-1200 does not have a display. If you want to read information from the device, you need a computer. The display on the S7-1500 is operated by using these buttons. The S7-1200, of course, does not have any buttons. When you open the front cover of the S7-1500, you will see two additional buttons labeled Start and Stop. These allow us to change the operating mode of the controller. If the CPU is in the stop mode, the transferred program will not be executed. The program is only executed in run mode. On some controllers of the S7-1500 series, there is a small switch to change the operating mode. If you want to change the operating mode of the S7-1200, you will need a computer again. The S7-1200 and the S7-1500 have status LEDs. These allows you to recognize if the controller is in run or in stop mode. Pending errors are also displayed here. These LEDs are a good first indicator when troubleshooting. And now, at the end of the video, comes the most important advice I can give you as a PLC programmer. The most important advice is, be like this worm. Before you start working with new PLC hardware, read the funny manual. Trust me, in the manual you find everything you need to know. If you want to work with Siemens PLCs, you should always have the manual available on your computer. Below the video you will find the link to the Siemens Industry Online Support. If you're looking for the manual for a specific device, simply enter the article number in the search bar. Then filter the results by manuals and select the latest version. The manual for the S7-1200 is only 1374 pages long. Of course, you don't need to memorize it, but you should always have access to it. In the manual, you will find a lot of information on selecting the right module, wiring, installation, commissioning and troubleshooting. If you want to save some time, ChatGPT can also be a very useful tool. I think everyone knows ChatGPT nowadays. The tool is very good for technical questions. Of course, you always have to check the results, but in 99% of the cases, ChatGPT provides the right answer regarding PLC hardware. Congratulations! You've watched the longest video of my PLC Basic course. Thank you very much. You're now familiar with the various Siemens PLCs and have gained a deeper insight into the current generation of controllers. I really hope to see you again in the next part of my course. Thank you so much for watching. If you're excited to dive deeper into PLC programming, visit my website at plccoach.com. See you in the next video.